All right, we're going to talk about what's called Gaussian elimination today. And then we're going to cheat and do it on the calculator. But there's a little bit of steps along the way that you're going to need to know for a quiz. And I will tell you exactly what it's going to look like on a quiz, okay? Ready, guys? All right. You can solve a system of linear equations using matrices. That was the whole point in getting excited about this chapter. We did all the review. We did the quiz without using matrices. Now we're going to get to use the matrices. The long way is called Gaussian elimination, and I'm going to show you how that works today. Okay? Basically, I'm making up a system here, so don't try to solve this because it won't work out well. Okay, when we had things like this, we did things like add these two together, and then maybe add these two together to get the x to drop out on the quiz last week. Yes? Everybody with me? Okay, we didn't write this, but this is what we really did. We added row 1 to row 3. And then we added row 1 to row 2. We just didn't call them rows. But we're going to call them rows because what we're going to do is we're going to get rid of the x, y, and z and just put the numbers down in a matrix, okay? That's going to be called the augmented matrix. And then we're going to talk about what it means to get it in row echelon form. So the augmented matrix is when you take all the coefficients, 1, -2, 1, and the answer of -1, and you put it in across row 1. 2, 1, -3, and -7 becomes row 2. 3, -1, 2, and 0 becomes row 3. Did I just say row 3 twice? Okay. So all of the x's are in column 1, the y's in column 2, the z's in column 3, and what the answer was to the equation is over here in column 4. So we ended up with a 3 by 4 augmented matrix that is equivalent to this system. Now, remember when we did things like add the rows together? We're going to do the same stuff. We're just not going to have the x, y, and z there. Okay? Now, remember what I said. Eventually, I'm going to teach you to do this in the calculator, so it's not going to be tricky at all. Before I go any further, I want you to practice. This is what it would look like on the quiz. It would say take -2 times row 1 and add it to row 2. And you would have to tell me what the new matrix looked like. We're going to practice this. Okay? We're going to practice this on the worksheet, but I just want you to know this is as hard as it's going to get on a quiz, okay? If I wrote this, because it ends with row 2 is what you're going to replace. Row 1 and row 3 stay the same. So I'm using this matrix. It would be 1, -2, 1, -1, 3, -1, 2, 0. Okay. Help me out here. -2 times row 1, and then add that to row 2. What would that become? -2 times 1 added to 2 would become 0. This is just because I want you to see it real quick what it's going to look like in a quiz. -2 times -2 would be 4, added to 1 would be... Everybody all right? -2 times 1 is -2, added to -3 would be... -2 times -1 would be 2, added to -7 would be... Okay? This is what it will look like on a quiz. I will give you a blank matrix, I will give you a matrix, and I will give you one step that I want you to do. One step given by me. And you have to do that. Does that seem okay? All right. They are going to do this a little more complicated because they're going to keep going to what's called row echelon form. Okay? Was there anybody who was confused about going from the system to the augmented matrix, just getting rid of the x, y's, and z's? That seemed okay? Okay. I just want you to understand the three things that we're allowed to do is interchange any two rows. If they're really just equations, does it matter which one we call equation 1, equation 2, equation 3? We could switch the order, right? Then it says you're allowed to multiply one row by a non-real number. So if I have an equation, is it equivalent as long as I do it all the way across? Like change all the signs? That's okay, right? So that's why this step is okay. Then it says you're allowed to add a multiple of one row to another row. So if I had another row underneath this, could I multiply this one by a positive 2 and then add it up to this one to get rid of the x? Okay, that's the same thing they're talking about here. Those operations are allowed. All right, so here's the example on your worksheet. They wrote, what is this guy called again when you leave out the x, y, and z? Augmented matrix. Okay. Then I don't like how they wrote this because that's not how I'm going to write it on a quiz. I'm going to write -2 times row 1 added to row 2. I think that's what we just did, wasn't it? The one I made up. We're going to do -2 times this top, add it to the second one. So it's going to change the middle row here. -2 plus 2 is 0. -2 times -2 is 4, plus 1 is 5. -2 times 1 minus 3 is -5. -2 times -1 is 2. Added to -7 is -5. Already got that one? The next thing we're going to do, and I would not write it like this, okay? I'm going to take a commercial break here. When I had to do problems like this without a calculator, what our goal was, given this crazy matrix full of numbers, okay, these were equal here, our goal was to get this to be a 1 and use that to clear out those two. Then to get this to be a 1 and use that row to clear out the zeros in column 2, make those zeros. And then to get this to be a 1 and clear out those. Why would that be a worthy goal? Do you remember what this is called? This is called the identity matrix. Do you remember that now? Okay. This is where I'm going, guys. What if at the end it said this? What would that mean? What would this row mean right there? 1x plus no y plus 0 z's equals 3. That would mean x was 3, right? What would this one mean? Y equals 2. And what would this mean at the end? Wouldn't that be peachy? We'd be done. So in a minute when the calculator does that for us, that's where we're going, okay? All right, that was my commercial break because we're going to see what happens on this one. All right, so we're going to do -3 times row 1 and add it to row 3. So from this matrix over here, the last one we used, we're multiplying this top row by -3 and adding it down to the bottom row. The reason is I want to get a 0 right here. But you don't ever have to make that rule up. I'm going to give you the rule. So -3 times 1 added to 3 is 0. What's -3 times -2? 6. Added to -1 would be? Okay. -3 times 1 added to 2. -3 times -1, 3, added to 0 is just 3, right? All right, they already did that here. Then they took this row and divided it all by 5 and got this. Remember when I said back in the good old days the goal was to get a 1 here and 2 zeros here, and then get a 1 here and 2 zeros here? Does anybody get what we would do to make this a 0 up here? Or a 0 down here? What would make that a 0 down there? Multiply this one by -5 and add it down to that one. Okay, so that's what we're going to do. We're going to do -5 times row 2 added to row 3. If I gave you that command, could you do that? So take row 2 times -5. 0 times -5 added to 0 is still 0. -5 times 1 added to 5 would be 0. -5 times -1 added to -1. -5 times -1 would be 5, and -1 would be 4, right? Positive? -5 times -1 is 5, added to 3 is 8. All right. Now what? What does it say to do? Divide that last one by 4, or 1/4. So we'd get 0, 0, 1, and 2. Now, this is called row echelon form, but not reduced row echelon form. Okay? Let me show you what I'm talking about here in 1 second. I have a slide that says that. Here. Look at this form right here, guys. When you have 1s on the diagonal, 0s below the diagonal, ignore this row for a second, and numbers everywhere else, okay? That's called row echelon form. If you happen to have an extra row of zeros, they go at the bottom. All right, back to where we were. We are in row echelon form. Where'd I go? Right there. Put this back into equations for me. X, Y, and Z. So the first equation is x minus 2y plus z equals -1. What's the second equation?
Y minus
And the last one? Okay, we can now solve. If z is 2, plug that into the one above it. We'd have y minus 2 equals -1, add 2, and we'd get y equals 1. If we plug both of those back into that first equation up there, we'd have x minus 2 times 1 plus 2 equals -1. Well, that's -2 plus 2, so we just get -1. So what did we wind up with? -1, +1, 2 as the solution. Remember what I said, the calculator's going to do this for us in a minute, but humor me on one more. Because I'm going to give you a step and you have to be able to do it. Okay. Again, this side is the identity matrix. If we have any extra rows, they're going to be at the bottom. This is going to be called reduced row echelon form when we have the identity matrix only left over there. All right, what's tricky about this first step on this problem? One, -2, 1, and 15. Everybody lost yet? Yes? The next row would be -2, -1, 2, and -1. That's what you'd enter in your calculator in a minute. What's tricky though? What's this third row missing? So it has to be -1, 1, 0, and -9. Do you understand why the 0 has to go here? Because it was the z that was missing. Everybody okay? What is this called? That's the augmented matrix. If I could spell. Okay. Now, Could you do this if I asked you, if I gave you this matrix? Could you fill this in? That's the only thing you have to know how to do for the quiz from this front side of the worksheet. When it says 2 times row 1 added to row 2, the row 2 is what's being replaced. So we copied over row 1, we copied over row 3, and now we're supposed to take 2 times, well, that doesn't look like a 2. 2 times row 1 and add it down to row 2. So 2 times 1 added to negative 2. 2 times negative 2 added to negative 1. 2 times 1 added to 2. 2 times 15 added to negative 1. Okay, guess what? On the quiz, there's not going to be a next one that has that row filled in already. Okay? All right. The next thing we're going to do is we're going to add row 1 to row 3. Because that's going to give us a 0 where we want it. Add these 2 rows together and replace row 3. What will it become? 1 plus negative 1 is 0. Negative 2 plus 1. 1 plus 0. 15 and negative 9. Okay. Yes. R3. Yep, sorry. All right, now, I don't like how they've written this, so I'm going to rewrite it. The next thing they did, oh, well, yeah, I'm going to rewrite it. They took negative 6 times R3 and added it to row 2. That's how they got this, and I'm just going to tell you that's how they got this. Does that sound like a plan? They did this row down here by negative 6 and added it to the one above. So negative 6 times 0 added to 0 was 0. Negative 6 times negative 1 is 6. Added negative 5 became a 1 right here. Okay, negative 6 times this became negative 6. Added to 4 was negative 2. Negative 6 times this was negative 36. Added 29 became negative 7. That's where they got that one. Now we're going to add row 2 to row 3. From this matrix right here. Add those 2 down. What do you get? 0. 0. We're adding down right here these 2. 0 plus 0. 1 plus negative 1. Negative 2 plus 1 is negative 1. Negative 7 plus 6 is? Okay. Change the signs on that row. So it would become a 1 and a 1, yes? Okay. I know you don't really get this, but we had to do a 1 here, clear out those zeros. We had to do a 1 here, clear out this column. Uh-oh. So we got to get rid of this. So we're going to go 2 times row 2 added to row 1.
So the only difference between the row echelon and the reduced row echelon
is we keep going. Yes, 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 exactly. 2 times row 2 added to row 1. That's what they did. So 2 times 0 is 0, added to 1 is 1. 2 times 1 is 2, added up here, they didn't do that. I lied. What did they do? Well, we're going to do it now. I don't know what they did. Okay, that's what we're doing here.
I think they did something to get rid of negative 2 in the third column.
Yeah, they did. Okay. They did 2 times row 3 added to row 2. My bad. I wouldn't have done that, but they did it. So now we're going to finish this one up, guys. We're going to take this row right here. So if I gave you this matrix and I said take 2 times row 2 and replace row 1, what would you get? 2 times 0 added to 1 would be 1. 2 times 1 added to negative 2. 2 times 0 added to 1. 2 times negative 5 would be negative 10 added to 15 would be 5. Yes.
How do you know which row you're replacing when it's written in different order?
I will write it so that it's the last row listed on the quiz. That's the way you have to do it in the calculator. If you were to program it into the calculator, whatever you add to, that's the row that is replaced. And I should have retyped the worksheet, and I didn't. All right, guys, to get the final thing, get rid of this final thing, we're going to take row 1 minus it. No, we're going to do this. I'm going to write it the way that it should be written. We're going to take row 3 times negative 1 and add it to row 1. That's what I would write on the quiz if I wanted you to do this. So down here at the bottom, I'm going to take negative 3 times this row down here and add it to row 1. So row 2 and 3 are going to stay the same. Negative 3 times 0 added to 1 is still 1. Negative 3 times 0 added to 0 is still 0. Negative 3 times 1 added... It's negative 1. What am I... Only because I'm recording can I not speak English about the proper thing here. I wrote negative 1. Yes, it was on row 3. Okay. Negative 1 times 0 added to 1 is still 0, or 1. Negative 1 times 0 added to 0 is still 0. Negative 1 times 1 is negative 1. Added up here is 0. Last one, guys. Negative 1 times 1 added to 5. 4. So now we have 1, 0, 0, 4, 0, 1, 0, negative 5, 0, 0, 1, 1. This is the identity matrix over here. The answers are x equals what?
4, negative 5.
Y equals negative 5. Z equals 1. Okay. We truly got to what is called reduced row echelon form this time, which is what the calculator is going to do for us. All right, before we type things in the calculator, though, we have to learn about systems that have no solution or many solutions. The command on the calculator is going to be RREF, which stands for Reduced Row Echelon Form. Reduced row echelon form will look like this, with some letters over here, some numbers over here. Whoops. It could also possibly have a row of zeros at the end. If there are any, you put them at the end. Or the calculator will put them at the end. It means nothing if there's an extra row of zeros as long as you already have A, B, and C solved right here. But on one like this, it means entirely something else. Right now, this says x minus 6z equals 4. Is everybody looking up here? Y plus 2z equals negative 3. But what does this mean? 0x plus 0y plus 0z equals 0. Yes, this is going to mean many solutions. And then we're going to have to do some more work with it. But what does this mean? 0x plus 0y plus 0z equals 1. Is that ever true? So that one's going to be no solution. All right, so here we go. What's the solution to this first one? Okay. What's the answer to this one? 0x plus 0y plus 0z cannot ever equal 1, so therefore there is no solution. You can just write no solution. It's fine. Yes? Oh. No, there will be a question just like this, though, where there's one of each. Okay. On this one, this first row says x minus 6z equals 4. The second row says y plus 2z equals negative 3. The third row says 0x plus 0y plus 0z equals 0. Because this is always true, we write many solutions. Unfortunately, we're not done. When it's no solution, you get to be done. When it's many solutions, you don't. What can these both be written in terms of? What letter do they have in common? Z. So you're going to write down here z equals any number. And then you're going to start a little ordered triple and you're going to put z. I don't know of any. Okay, we're going to put down here at the bottom z for z. But instead of y, for y, I want you to solve this in terms of z. So y plus 2z equals negative 3. If I subtract 2z over to the other side, it will say y equals negative 2z minus 3 or negative 3 minus 2z. I don't care which. Do the same thing with x. What will this one become? X minus 6z equals 4. If you get the x by itself, it will say what? 4 plus 6z or 6z plus 4. Either way is fine. Okay. So it says many solutions where z can be any number, and then you have to do negative 2 times that number minus 3 to get the y, and you have to do 4 plus 6 times that number to get the x.
Could we put the all real numbers in hypothesis, like the r with the 2?
You can. If I picked 0 here, what would the ordered triple look like?
Or negative 3.
What if I picked 1 for z?
Negative 5.
Put a 1 in, put a 1 in, put a 1 in, right? There's infinite solutions because z can be any number. All right, here we go. I'm going to try them on the calculator. You're going to put it in matrix, the augmented matrix, in by editing and placing it in the calculator. Then you're going to go to Math under Matrix and find RREF and put that in the home screen. Okay, so here's calculator. How do we get to the matrix? Second, and then the little x to the negative 1, which is going to be the inverse button for matrix when we do those tomorrow. Arrow to the right twice, because in order to be able to put a matrix in, you have to be under Edit. Okay, I'm going to put it in A, so I'm just going to hit Enter, and then I have to know what size it is. What size am I going to use for this one? This is what I'm going to enter, and I'm going to write it down. You don't have to write it on your paper. But I think for your notes once, it might help to write it down once. But this is the augmented matrix, and you can put the little dashed in there if you want, but you don't have to. And that's how you type 3, enter, 4, enter. Now, I will tell you, if you make a sign mistake or you put a number in the wrong spot, yes, you're going to get totally different answers. So after you get it typed in, I suggest you proofread it before we quit out of this screen. Make sure you hit enter behind every one. When you are sure you have entered it correctly, you need to quit, because you have to be back in the home screen to do RREF form. Everybody okay? Second mode to quit. Got it typed in? Okay. We're going to go back to the matrix. So second, the x to the negative 1. We're going to go right to the math. We're going to perform some math. It's hidden because I used to not tell students how the calculator would do it. So it's way down at the bottom. I usually go up arrow to find it. It's B. Did you find it? Don't use A, because then you'll still have to do some work. It won't give you the whole identity matrix on the left thing. Okay, reduced row echelon form. You do have to tell it of what matrix, so I stored mine in A. So I have to go back here and just put the name. Second matrix, and then whatever number you have it in. Got it? Then just hit enter. It's a beautiful thing. Yep. The RREF, second matrix, arrow to the right, and scroll up or down. It's B. And then on the home screen, and then you have to still put the name of the matrix in. Okay, so this then gave us 1, 0, 0, 2, 0, 1, 0, negative 1, 0, 0, 1, 3, which is reduced row echelon form. And the answer to this question is 2, negative 1, 3.
Never have to solve the system again.
Because we used to make them do, like I just taught you, with the 2 times row 3 added to row 1. Yes? No. All you have to honestly do is write this. Okay? Start me out on number 2. And if someone's a fast typer, they can type it in. But then I'm going to skip it and go on because I want to get to the word problem. And we got a no solution and a many solutions to do yet. But I want to know what, because there's going to be some zeros here, right? What's this one going to look like when you go to type it in? So 3 by 4 still. Okay. 1, 0, negative 1, 2. Now, if you just did this, if you have this on your screen, home screen still, you can just hit enter. And it'll give you the reduced row echelon form of the new matrix A that you put in, okay? Which is going to be different than mine because I didn't put it in. You don't even have to type anything. If you just hit enter, it'll repeat the same command you just did. What did you get?
3, negative 2, 1.
Okay. Yes? We're good? All right. Who's furiously typing this one in? I don't think it is. Is the last row all zeros or not all zeros? Because they're two different things. If it's all zeros, then it's not no solution. It's many solutions. Okay, I have no idea if I typed that in right. I'm not going to even take time to proofread it. Is that what you got? Okay, so This means that we have a row of zeros, which means many solutions, right? Many solutions. Then it currently says x minus z equals negative 6. The second equation is y minus z equals negative 7. So what can be any number? Z is going to be any number. And then we're going to write z. And how do we get this to say y by itself? Add z. And we'll have y equals negative 7 plus z, or z minus 7. And what if we solve this one for x? We'd add z again. So we'd get x equals negative 6 plus z, or z minus 6. Okay? That's all you have to do. Could you find some points if I asked you to plug some numbers in? Yeah. Okay. Can I tell you what number 4 is?
Go ahead.
If you do number 4 at the end, you get this. That's the last line, so you get no solution. And you get to be done. Those are the kind Kate wants a lot of. All right, let's look at the word problem. Don't even bother to read it. Read the last sentence only to yourself. What are we trying to find? Number of each item that was built. Now go to the top. What are we actually building? Okay, so I could use T, C, and S, but I'm just going to use X, Y, and Z. Number of tables. Number of chairs. And number of stools. Okay, somebody come up with one of the equations. Okay, 4 times the total number of tables and stools built. The number of chairs was 4 times. Chairs was 4. Okay, we missed a really easy equation though. What did this say? Okay. Now there's an easy equation that has to do with money. But be really careful because they don't do it in the same order for some miserable reason. A chair is $150, so that's a Y. 150Y. A table is 200, that's an X, so 200X. And a stool is 75. And that would give us $42,125 for the week. Okay. Before we can enter this into a matrix on our calculator, I need to do what to this equation right here? I have 4x plus 4z equals y. Somehow I have to make it say equals 0, right? Yeah, I can move it over here. It doesn't matter. It doesn't matter if you put 4x minus y plus 4z equals 0 or the other signs. It doesn't matter about your signs as long as they're consistent. Okay, put it in your calculator. I don't know why when I get to the bottom I always start going backwards. When I get to the bottom of my screen I start going right to left. You get 40 220 and 15. If you didn't, it's probably a sign mistake somewhere and I can help you. But so we did 40 tables, 220 chairs, and 15 stools. A large part of the homework is word problems. But the first few questions, guys, say write the augmented matrix. That's all you have to do, okay? So they're not all complicated.
Even the word problems are really.
Yeah, even the word problems, once you write the equations, are easy. All right, so this is the book work you need to be working on tonight.